Okay, we're going to do L'Hopital's rule here. And L'Hopital's rule, spelled funny, L apostrophe, spelled like this. It's pronounced L'Hopital. Sometimes you see an S in there. It's a rule that helps you with limits that are indeterminate. So here's an example. Say we're trying to find the limit as x approaches 0 of tangent of x over 6x. Okay, so when you do a limit, generally you just plug numbers in. But when you do that, you get 0 over 0. It's called an indeterminate form. It's not really 0 over 0. It's a number very close to 0 divided by another number very close to 0, and we don't know at what ratio they're approaching 0. So it tells us absolutely nothing. But L'Hopital's rule suggests that if you get an indeterminate form, just take the derivative of top and bottom and try again. Okay, so if you do that, you get secant squared x over 6. Again, plug the 0 in. Secant squared 0 over 6. Well, the cosine of 0 is 1. Cosine of 0 radians, so the secant of 0 radians will be the reciprocal of 1, which is still 1, and 1 squared is 1. If you're going straight in the calculator there, you would say 1 divided by cosine of 0 quantity squared. But it's 1/6, so this clearly is not an indeterminate form. So that's our answer. Okay. Another example. Let's say we have the sine of x minus x over x squared. And we're trying to find, again, the limit as x approaches 0. If you plug numbers in, it's sine of 0 minus 0 over 0 squared. And 0 minus 0 over 0. So that's 0 over 0. It's still indeterminate. Okay, so we'll take the derivative of top and bottom. Derivative of sine is cosine. Derivative of x is 1. Derivative of x squared is 2x. So if I plug the zeros in this time, cosine of 0 is 1, remember? Zoom in a little better. So that's 1 minus 1 over 0. That's still indeterminate. So this is an illustration to where you can just continue to use L'Hopital's rule. If it's indeterminate, try again. If you're still indeterminate, so let's do that. Get a board. I'm going to carry on here, and this time I'm going to work on this one. So limit as x approaches 0, the derivative of sine is, cosine is negative sine over 2. So clearly this is not going to be indeterminate. So negative sine of 0 over 2, that's 0 over 2 or 0. Okay, so that 0 is not indeterminate. That's the answer. It's just 0. Right. It also can work with infinity over infinity. So we'll show you an example of that. A third example. Let's say that we have a limit as x approaches infinity. We're going to do natural log of x over x. Okay? When you put infinity, now you're not really putting infinity in. You're putting numbers that are very big in, and what tends to happen when you put bigger and bigger numbers in? Well, the natural log of something very big is very big. And again, if you put a number that continually gets bigger, this approaches infinity. So there's no such thing as the number infinity. This is just a very big number divided by some other big number, and we don't know what ratio they're going at. So this is indeterminate. Okay, so L'Hopital's rule, again, says I can just take the derivative of top and bottom. So the derivative of the natural log of x is 1 over x. The derivative of x is 1. 1 over x divided by 1 is x. Okay, so let me write my limit. Okay, and if I put infinity, again, and put infinity in is, you don't really do that. If you put a big number in for x and you let it get bigger and bigger, 1 divided by that number is going to get smaller and smaller. So I said, okay, if I put 1/2 and then 1/3 and then 1/4 and then 1/100th and then 1/1000th, and so forth, this is getting large, and therefore the result is getting small. So this limit would be 0 as well. So you're going to get some zeros, you're going to get some ones. So that's some basic L'Hopital rule